No one's looking out. I just want to think of the first one was.
Disraeli, Aubrey, wasn't it? Disraeli.
That's it.
On Budget Day, the Chancellor's Exchequer must be the most famous man in Britain. By this evening, every member of the population will have had the opportunity to see the news, irrespective of whether this is in print, or as pictures, or as television film. It will have been the result of some photographic process. It's impossible to imagine a world without photographs. But even when these were invented 150 years ago, it took several hours to make a single exposure. Smile, please. Cameras are a great deal older than photography itself. Here at Bristol, overlooking the famous Clifton Suspension Bridge, is a rather interesting one, built into an old snuff mill. It's called a camera obscura. At the top of the tower is a mirror and lens, which throw pictures onto a screen inside. The image isn't very bright, but if you look carefully, we can see one of the towers of the Clifton Suspension Bridge. And if I now move this handle, which rotates the lens housing on top, we come into the bridge approach, and now we can see the town of Clifton. The camera obscura was invented about 400 years BC and used a pinhole instead of a lens. Rays of light from the outside scene pass through the hole and cast an image upside down on the wall opposite. They were soon made more portable and put to some very interesting uses. The effect was quite magical, and camera obscuras became a popular source of entertainment. They even found their way into the fine arts. It was Giovanni Battista Porta who first suggested the use of the camera obscura for painting. And it was Canaletto, together with many other artists, who took up the suggestion. It enabled them to get an entirely different view of how to get at perspective. But not everybody was as good an artist as Canaletto, or indeed me. And it was the desire to faithfully capture the images of the camera obscura which led to the discovery of photography. Here at Laycock Abbey, deep in the heart of Wiltshire, William Henry Fox Talbot, one of the principal pioneers of photography, lived and worked. He was born in 1800, and it was while struggling to draw Lake Como during his honeymoon in Italy that he conceived the idea of making the pictures record themselves. It is this which earned Fox Talbot the title of the father of modern photography. It's the world's first negative, and he inscribed it as having been taken in August 1835. It was taken with a little camera here, into the back of which he had inserted a piece of a sensitized paper. The subject was this latticed window here. And what I have here is a positive print of the same negative, and we can see how good its resolution was because we can count every one of the 200-odd little panes which make up the window. But long before this, in 1725, Professor Heinrich Schulze had discovered the effect of light and silver salts whilst trying to make phosphorus. To do so, he was using nitric acid, which had become accidentally contaminated with silver, so that it contained some silver nitrate. He was using a round-bottomed flask such as this to do his experiment in, and he found that the thick precipitate, which gathered in the bottom of the bottle, turned dark where it faced the light. Now I've repeated the experiment here, and I've protected some of the precipitate by leaning my pen against it. If I now take the pen away, we can see that that part of the precipitate, which has been protected, has remained light, while the surroundings have darkened. Tom Wedgwood was the very first person to put this to practical use 75 years later. He came from the famous Wedgwood family, was brought up in contact with many distinguished scientists. He was fond of practical scientific experiments. When the potter received an order for a huge dinner service decorated with pictures of English stately homes, Tom set his mind to recording them directly with his camera obscura. He coated white leather and paper with silver nitrate. With the help of Humphrey Davy, produced images by exposing this paper through etchings. However, it wasn't fast enough to allow him to get any sort of image at all in a camera obscura. Worst of all, he had no means of desensitizing his coating, so when his pictures were exposed to the light, they went black again. A Frenchman, Niepce, was next, but like Wedgwood, he had problems fixing his pictures. Working from a chateau in the Bourgogne, he experimented with another material, a kind of bitumen, which is hardened by light, and in 1826 produced this, the world's first photograph. Also hard to see is in fact the view from his workroom window. In 1830, Niepce joined forces with Louis Daguerre, an artist. 9 years later, they were ready to launch the first practical system of photography. Called the daguerreotype, it was offered on sale to the general public. This is a complete kit, together with its instruction book. £200 would buy you everything to turn you into daguerreotypist. Now, it started off with a copper plate, which was thinly plated with silver, and then brought to a very high state of polish indeed. The polished plate was then sensitized by being exposed to iodine vapor in this box here, in the bottom of which there is a dish filled with iodine crystals. The plate, once having been sensitized, is then exposed in the back of the camera, and having been exposed, a very faint image could probably have been seen. The plate was then put into this box here, into the bottom of which there was a pool of mercury, which was kept heated by means of a spirit burner. The mercury vapor inside this box then greatly enhanced the image. The detail that could be captured was staggering, as you can see in this picture of the Cincinnati waterfront. But the main use was for portraits, and here was a method of making them cheaper than ever before. Portrait studios sprouted up all over the world. Richard Baird was the first to open one on the roof of the Polytechnic in London in 1841. The results were absolutely exquisite. The daguerreotypes were supplied complete with a frame and covered in glass, but they suffered from two major disadvantages. The first one was that it was very critical from which angle they were viewed. View them from the correct angle and they look beautiful, tilt them slightly, and the positive turns into negative. This meant one couldn't easily hang them on the wall because one couldn't ensure that they were viewed from the right angle. The second disadvantage was that the actual result was a plate which had been exposed in the camera, and in consequence it was very difficult to make copies. Now, we'd already seen that in the meantime Fox Talbot had developed his own photographic process, and he called his paper photogenic drawing paper. Now, he made this by soaking paper in a solution of common salt, that's sodium chloride, and then painting the surface with a solution of silver nitrate. And this precipitated tiny crystals of silver chloride in amongst the paper fibers. In order to use this paper, you put some translucent object, such as a leaf, on top of the paper, and then exposed this combination, clamped in a printing frame such as this, to the sun for several hours. Now, after this long exposure, he got a print. And we see one here. Now, in those parts of the paper where light had struck the paper, some of the silver chloride was turned into tiny particles of metallic silver. In other parts, where less light is struck the paper, it was paler, and in those parts where no light is struck at all, it remained completely white. Now this, of course, is a negative. In order to make it into a positive, he took another piece of paper, prepared in exactly the same way, sandwiched it with his negative, exposed the sandwich to sunlight again, and then, lo and behold, when he peeled the two layers apart, he was presented with a beautiful positive. Fox Talbot was completely taken aback by the announcement of the daguerreotype in 1839. He rushed to display his photogenic drawings and delivered a paper on the subject at the Royal Society, so as to lay claim to the invention of photography. Now, Fox Talbot also took pictures of objects which he couldn't actually put into a printing frame, such as buildings, by putting a piece of his paper into a camera obscura. The trouble was that shots like this took hours to make, and he realized that to compete with Daguerre, he had to reduce the exposure time from hours to minutes. To do this, he sensitized the piece of paper in a similar way to his photogenic drawing paper, and after blotting came an all-important second stage. Now, just before exposure, and this is of course what gave it the enormously increased sensitivity, a piece of paper which had been prepared in this way and dried was coated with the exciting fluid, Fox Talbot's exciting fluid, which was a secret for the increased sensitivity. This, having been prepared just before use, consisted of gallic acid, acetic acid, and silver nitrate. Now, the paper having been completely coated with the exciting fluid was then blotted, and while still damp, was cut to size and loaded into a dark slide, just as this, and was ready for exposure. Fox Talbot had managed to enhance the sensitivity of his printing out papers by the addition of gallic acid. He experimented how sensitive they really were and reduced the exposure and further reduced the exposure until one day he extracted a piece of paper out of his camera which showed no visible image at all. He put this aside and on some subsequent occasion resensitized it by painting the exciting fluid onto it again, and to his amazement found that a visible image appeared. Now, what he had discovered was the process of development. Now, the concept that one can store a latent image on a piece of photographic material and subsequently enhance it by an enormous amount by development is something which is absolutely central to the science and practice of photography. Here's a picture. But it wasn't until this century that we began to understand how this process works. This model is a hugely magnified section of a modern silver halide crystal. When it is exposed to light, an electron is released and moves to a place made attractive to it during manufacture. It is then ready to join with a passing silver ion and turn it into an atom of solid metallic silver. A group of 3 or 4 of these atoms is all that is needed for the entire crystal to be exposed and ready for development. The latent image is made up of billions of exposed crystals, but because the silver atoms are so infinitesimally small, the picture is completely invisible. Today, film still relies on Fox Talbot's unique discovery, the development of the latent image. Modern developers amplify the effect of the light by 100 million times. They act as an electron donor, causing a sort of chain reaction to occur within each exposed crystal. More and more silver ions are affected until the entire crystal is turned into solid silver. Fox Talbot called this process the calotype, after the Greek kalos, meaning beautiful. In 1842, he set up a photographic establishment in Reading. Here he printed pictures for the first photographically illustrated book, The Pencil of Nature. Calotypes suffered from one major problem, lack of sharpness. The image looked fuzzy because of the fibers in the paper negative. Then, in 1851, came a new photographic process which overcame this and eventually swept the calotype aside. Frederick Scott Archer, an Englishman, conceived the idea of coating glass plates with collodion in order to carry the light-sensitive salts. Collodion is an early plastic made by dissolving gun cotton in a mixture of ether and alcohol. He made his plates by pouring the solution of gun cotton onto the plates, allowing most of the solvent to evaporate to make them tacky, and then sensitized them by immersing them in baths of potassium iodide and silver nitrate. Once sensitized, it was essential that the plates were exposed and developed while still wet. Unfortunately, all this had to happen in the dark, so he had to carry his own darkroom around with him. Despite his inconvenience, wet collodion photography caught on fast, and itinerant photographers hauled their cumbersome equipment all over the place. One of the most famous was Roger Fenton, who took hundreds of pictures throughout the Crimean War. This is a valley of death, strewn with cannonballs. Back in the portrait studio, wet collodion photography took everybody by storm. Even Queen Victoria had a darkroom installed in Windsor Castle. What made the process more attractive was that it was more sensitive, so reducing exposure times from minutes to tens of seconds or even seconds. Before the wet collodion process, it was impossible to capture movement. This calotype was exposed for several minutes. You can just see the ghostly images of a cart and a group of people as they pause briefly on their way through. In order to cope with the long exposure times, this gentleman had to be suspended in his pose by a piece of string tied round his wrist. When people were used to pictures like this, it's understandable why these caused such a stir. Moving vehicles could be seen, ripples of water were captured, and skies with sharply defined clouds were possible using the new process. The increased sensitivity meant that sitters no longer had to be clamped in place, and that photographers could use more of the daylight hours. Scott Archer, unlike Fox Talbot, couldn't afford to patent his process, so that photographers did not have to buy a license, and this in itself enormously increased the popularity of portraiture. In daylight studios, the amount of sunlight entering through the skylight could be controlled by blinds such as these. Tom Reeve still uses a studio built in 1857, but in spite of more sensitive plates, his great-grandfather still occasionally gave the son a helping hand. Thousands of portraits were taken in the studio. The printing paper was made by coating paper with egg white containing ammonium chloride and sodium chloride, then dipping the dried paper into a solution of silver nitrate just before use in order to sensitize it. The negatives were all created on wet collodion plates. We have one here, which exhibits the characteristic white sheen. Now, this method of photography persisted virtually unchanged throughout the whole of the Victorian era. Street Life in London, published in 1877, is the first piece of genuine photojournalism. John Thompson left the studio and took these pictures outside on the streets with real people. But by the end of the 19th century, wet collodion was being replaced by dry gelatin. The gelatin emulsion was coated onto glass plates, which were then exposed dry and could be kept for a long time before they were developed. The advantages were obvious. Photographers no longer had to carry a darkroom and chemical store around with them. Photography became truly portable and much easier to use. There were some teething problems with the early gelatin emulsions, because their sensitivity seemed to depend on what the cow, from whose bones the gelatin was made, had been eating. If it had been eating oniony plants, the emulsions were more sensitive. But this was soon sorted out. And also, by 1881, the heavy glass plates had been replaced by rows of celluloid film, which were coated with a gelatin emulsion. This was the first popular camera, the Kodak #1. And as the advertisement said, you take the pictures and we do the rest. What actually happened was that once one had exposed the pictures, the entire camera was sent back to Kodak, where the film was processed and printed. At this time, the printing was still done by sunlight, under the glass roofs, or in the open air like this. There was only one further development required in black and white photography in order to make the link to the present day. Up to the 1890s, emulsions were really only blue sensitive. And then in order to improve the rendition of the gray tones, the sensitivity was first extended to the green and then to the red part of the spectrum. This really made color photography possible. I've loaded these three projectors with three black and white transparencies, which were taken respectively through a red filter, and a green filter, and a blue filter, so that each black and white transparencies records the intensity of red, green, or blue light being reflected back from the scene. If I now project these three transparencies through the appropriate filters in exact register onto a screen, I can recreate the original color of the scene. It's a long way from that magic lantern to the magic which resides in here, and it's all due to the pioneering work of William Henry Fox Talbot.
Now I'm a young inventor, a chap with good ideas. I've built myself a camera, it took me years and years. It's a wonderful invention with special X-ray tricks. It can take a picture in the dark and can even see through bricks. I bought myself an album and filled it up with snaps, and I've got some lovely pictures of the local girls and chaps. Now I've got a picture of the girl next door in my little snapshot album, and I've never had a better snap before in my little snapshot album. The night was dark and the hour was late. She was kissing her boy by the garden gate. Hey, wouldn't she love to see